Hi everybody, welcome to our section 2.1 lecture video on the introduction to variables. So first thing we're going to start off with is some vocabulary. Whenever you hear the word terms, terms are always separated by addition or subtraction. Okay, so when you want to figure out how many terms are there, well, you can kind of find the addition or subtraction and then see what is separated there. So the 7y and the 3 would be different terms in this expression. Here's my subtraction, my addition down here. So 4, 6a, and 5b would be my terms in this one. Okay. When you hear the word constant, a constant is a term that doesn't have a variable part to it. It's just a number by itself. That's one of your terms. So it's a term with no variable. So down here, just the number 3 would be a constant, or just the number 4 would be a constant, okay? So then what's a variable? A variable is an unknown quantity, and we generally represent that with a letter. So it's an unknown quantity in math. And generally you can tell it's a variable because there's a letter to it. So the y here would be a variable, or the a down here, or the b over here. Those would be variables. The coefficient is a number multiplied by the variable. So with the 7y, the 7 would be a coefficient. Okay? So it's a number that multiplies a variable. So multiplying a variable. So in example 1, we've been doing this throughout, but let's go ahead and actually write down the answers here. Identify the number of terms for each expression, then identify constants, variables, and coefficients in each one. Okay. So in A, I have 7y plus 3. You notice I already circled the plus, and we can see here that I have two terms. So 7y is one of my terms, and 3 is a term. So there are two terms. So then for constant, so the number 3 is a term that has no variable in it. That's a constant. So constants would be that 3. Variables would be a number that I don't know, which is represented by a letter. So the y here would be a variable. And the coefficient for the y would be the 7 over here. It's the number that the y is multiplied by. Okay, let's do another one. In part B, I have 4 minus 6a plus 5b. So this time, I have 3 terms. So 4, 6a, and 5b are all terms. So this time, do I have a constant? I do. It's just that 4 at the beginning. That's a term that doesn't have a variable with it. Okay. Do I have any variables? I do. I actually have 2 variables. I have an a and a b. So I've got 2 different variables there. Okay. And do I have any coefficients? Both of those have coefficients, so the a has a coefficient of 6, and the b has a coefficient of 5. Running out of space over here, but 6 for the a, 5 for the b. Okay. A little bit more with vocabulary in an expression. X to the a, x is considered the base. And that little a up top is called the exponent. And that exponent describes how many times the base is multiplied by itself. Okay. So in example 2, we're just going to deal with exponents for a moment, rewriting each expression without any exponents. So we're just going to kind of write it out a long way or expand those out. So I have w to the 4th. So what that means is that w is multiplied by itself 4 times. So that would be w times w times w times w. There are 4 w's being multiplied by themselves. That's what w to the 4th means. In part B, I've got 5a to the 3rd, b to the 2nd, c. So I just have 1 5. I'll have 3 a's that are getting multiplied together. B squared means I'm going to have 2 b's that are multiplied together. And then I have a c at the end, so then I have 1c. So that's what those look like without exponents, so that you kind of understand what's going on. Next little terminology is the word evaluate. Sometimes you're going to see that in the instructions. It's going to say evaluate each expression. And so what that means is that they're going to have an expression, and then they're going to tell you what the variable equals. You'll substitute that number in, and then use order of operations to get it down to just a number. Okay? So how do you evaluate an expression? You're going to substitute or plug in, if you want to think of it that way, substitute a number for a variable, or for each variable if you have more than one. Then what you'll do is you'll use order of operations to get it down to just one number. You're going to perform all of those operations using the order of operations. So let's try some of those. So in example 3, evaluate each expression. So in part A, we have r squared, and it tells us that r is negative 3. So the first thing I'm going to do is I'm going to substitute negative 3 for r. So what that looks like is negative 3 squared. And you'll notice I put a parenthesis around negative 3 because I want the entire thing to be substituted in. I don't want to just square the 3, because that's not what all r is. R is negative 3. So I want to make sure that entire number of negative 3 gets squared. Okay? So if in doubt, I would honestly just put them all in parentheses and deal with it from there. So now I've got negative 3 squared. So that would be negative 3 times negative 3, which would be 9. And so if you're curious, how do you know when you're done with one of these evaluating questions? You're going to get just a number at the end without any operations left. That's when you're done. Let's do another one. In part B, I've got c to the 3rd, d to the 5th, and I know that c is 4, and I know that d is negative 1. So first step is we're just going to substitute those in. I'm going to put 4 in for c, so that would be 4 to the 3rd. Then I'm going to put negative 1 in there for d, so that would be negative 1 to the 5th. And then I'm going to keep going. I'm going to do those operations. So I'm going to start with exponents first. So 4 to the 3rd would be 4 times 4 times 4, which is 64. Then I'm going to do negative 1 to the 5th, so that's negative 1 times negative 1. So negative 1 times negative 1 would be positive 1, and then positive 1 times negative 1 would be negative 1, times negative 1 again would give you positive 1, and then positive 1 times negative 1 is negative 5, or is negative 1, not negative 5. So it is negative 1. And it's okay to use your hands and use your fingers, okay? Don't feel self-conscious at all about that, to keep track of where you are. So now that I've done that, then I can use multiplication. So 64 times negative 1 would give us an answer of negative 64. Okay, let's do a couple more. So next one is 3x to the 5th minus 4y squared. And we know that x is negative 2, and we know that y is negative 5. So we're going to substitute those values in first. So I'll have 3 times negative 2 to the 5th minus 4 times negative 5 squared. Okay? So with order of operations, we should be doing the exponents before multiplication or subtraction. So we'll start there. So negative 2 to the 5th. So that's negative 2 times negative 2 times negative 2 times negative 2 times negative 2. We're going to do it 5 times. So let's go in order here. So negative 2 times negative 2 would be 4. Times negative 2 again, so that's 4 times negative 2 would be negative 8. Now I've got 8 times negative 2 would be negative 16, or sorry, positive 16. And then 16 times negative 2 would be negative 32. So now I have 3 times negative 32. My next one over here, I got negative 5 squared, so that's negative 5 times negative 5, which is positive 25. So I've got 4 times 25. Okay, now that we've done that, we should be doing multiplication before subtraction. So let's do that. So I've got 3 times negative 32. So 3 times 2 is 6. 3 times 3 is 9. And a positive times a negative gives us a negative. So 3 times negative 32 is negative 96. Okay? Then we have 4 times 25, which is 100. You could even think about quarters. 4 quarters gives you $1. 4 times 25 is 100. So now I have negative 96 minus 100. And we're ready to do our subtraction, okay? If it helps your brain a little, that's the same thing as negative 96 plus negative 100, if that helps a little bit with doing the math. Negative 96 plus negative 100 would give us negative 196. And we're done. We don't have anything else we can do to that problem. So that's the answer. Last one, in part D, I have the absolute value of a times b plus the absolute value of ab squared c. And I know that a is negative 7, b is 4, and c is 11. So first thing I'm going to do is substitute those values in. So I'll have the absolute value of a times b. So that would be the absolute value of negative 7 times 4. Plus, then I'll have the absolute value of ab squared c. So that would be the absolute value of negative 7 times 4 squared times 11. Okay. So I should be doing what's in the absolute values first and then taking those absolute values before doing the addition. So in the first absolute values, I've got negative 7 times 4. Negative 7 times 4 is negative 28. And the absolute value of negative 28 would be positive 28. In the other absolute values, I've got negative 7 times 4 squared times 11. I need to do the 4 squared first, which would be 16. So now I've got the absolute value of negative 7 times 16 times 11. Okay. You can do this in whichever order. I'm probably going to do the easy ones first. How about we do negative 7 times 11 first, which would be negative 77. And then over to the side here, I'll do 77 times 16. 6 times 7 is 42. 6 times 7 is still 42. And 42 plus 4 would be 46. A 0 as a placeholder. 1 times 7 is 7. 1 times 7 is 7. Add everything together. And I get 1,232. It will be a negative since I've got a negative times a positive. So now I have the absolute value of negative 1,232. The absolute value of negative 1,232 would be positive 1,232. So now I have 28 plus 1,232, and I just need to add things together. See in the ones column, 8 plus 2 would be 10. In the tens column, 2 plus 3 is 5, plus 1 would be 6. In the hundreds column, I just have a 2, and in the thousands column, I just have a 1. So my answer is 1,260. Okay, so we've seen some varying levels of difficulty with these evaluating questions. Hopefully that helps you guys. If you have any questions along the way, let me know. Good luck today.